Hello and welcome everybody. It's 1 o'clock Eastern time and that's our scheduled time to start. For those that don't know who I am, my name is Steve Teresi. I'm the Director of Training and Technical Services here at JL Audio. I'm located down in Southern Florida, just a few miles north of our main headquarters in Miramar. I have with me Mr. Rob Haynes over in Southern California. Say hello, Rob.
Hello, Rob.
Very good. And of course, up in Pittsburgh, Pennsylvania, I have Mr. Kevin Ferry, who'll be presenting today. Say hello, Kevin.
Hello, everybody.
Fantastic. So what we got going on today is we have some people that have joined us on WebEx. Those of you on the WebEx call, on the right-hand side of your screen, you should be able to see the chat function. If you don't see that, move your cursor along the middle of the screen. To the bottom there, you'll see the option to click on the little chat bubble. It'll open up there. Rob and I will be keeping an eye on that chat. So if you have any questions for us, just poke them in there. Kevin won't be able to see those, so don't be asking Kevin anything direct because he won't be able to see it right away. Similarly, over on Facebook Live, we are streaming there right now. There's a slight delay for those in the Facebook group. So if you have some questions or comments, you could pop them right over there. And again, Rob and I will be keeping an eye on that. Kevin will, again, be blind to some of those things until after he's done presenting. So just as a reminder, these sessions have all been structured in such a way that they're intended to be pretty short in terms of their duration. 30 to 45 minutes is our target, and sometimes we hit that target, sometimes, usually when I'm not talking. Additionally, we also know that you're very focused in the work that you're doing at wherever you may be, at home or at work, or whatever the case may be. So we do respect your time and want to stay on track for things. So without further ado, I'll let Kevin take over from here. Go ahead, take it away, Kevin.
Alrighty, you guys should all be able to see my session agenda or our session agenda for today. Alrighty, so kind of the session agenda for today is we're going to talk about our key amplifier technologies. We're going to go into some of the engineering that is done here in the USA and then kind of finish off with some questions at the end. We probably will be on time with this training. We'll see how much Steve and Rob interrupt, but I'm sure Steve will have some cool tidbits to jump in on and talk to us about. So the good news is I've purposely made this training about 5 to 10 minutes short for those great interjections and the great content that they both bring to the table. So. So, as many of you may know or not know, JL Audio is based in Miramar, Florida, just in between Fort Lauderdale and the Miami area, with the majority of the production being handled down there at the mothership. However, our electronics division is actually based in Phoenix, Arizona. All JL Audio electronics, such as amplifiers, Media Master, Bluetooth, and DSP products are actually engineered and designed in our Phoenix location. And we have a third office located up in the Pacific Northwest, up in Portland, Oregon. And they house all of our DSP team, who is responsible for all of the software and firmware design, testing, for products like the Media Master, any of our Bluetooth products, and all of our DSP products also. So this is one of our guys up in the Portland office. He was one of only 2 engineers for quite some time. Now we've got a larger group in a larger office going on and all of that too. It's pretty cool. Some of the equipment that they have is able to talk to the different locations. So we can hook up an amplifier in Phoenix, Arizona, and they can go in and run a full gamut of testing and diagnostics on that amplifier from the Portland office, and they can do it vice versa too. They can hook up stuff in Portland and we can go ahead and check it out in Miramar, Florida. It's a very cool, complex network of computers that really talk to one another and really give us a lot of information and data and bring all of the different locations together to be able to work as one team on each individual product.
Good to see you starting already. The Portland team not only has expanded in terms of number, but in the physical space as well. So we have, I don't know, 10 or 11 engineers up there now, and the space that they used to have was a pretty modest size office. It was just enough room for their lab and a couple of desks, and that was about it. So when we started adding additional engineers, we needed to get more space. And now we take up almost the entire top floor of the building that they were located in. It's a significant improvement. Of course, just moving from downstairs to upstairs is never as easy as you might think. So that was quite an undertaking. I wanted to make sure that people knew about it.
I'm shocked they had so many people in that office, because when I went there, there was only 3 engineers, but these are engineers, which means there is stuff everywhere. And I felt claustrophobic in there. So I don't know how they squeezed 8 more engineers in that office, but
Exactly. Yeah, it's crazy. Conference calls are always great because you could see through one camera almost everybody. So,
Right? Yeah, you can see all the different guys in the background there. There's literally the same size as my home office is, and I'm the only person in it, so I'm sure they're all happy to be a little bit better spread out there too. So when we start going through and talking a lot about these technologies, keep in mind that they are all designed and engineered here in the US by the group of engineers who are also enthusiasts with over 450 years of combined electrical engineering experience alone. I mean, think about that. 450 years of experience just in electrical engineering. So there's a lot of brain power that goes behind a lot of these technologies.
I'd like to add on that, Kevin, not only is it just a whole bunch of combined engineering knowledge, most of them have worked together for the majority of their careers. So it's not even that they're just smart, but they know each other so well that they can develop and play off of each other really effectively. And that when you keep a team together for as long as we have, both at JL Audio as well as some of their previous careers, it really does magical things. You kind of know, I know exactly what Kevin's thinking when he does this, or, Rob is always doing things like this. We know what to expect. It really does help streamline and improve things.
It does, absolutely. So I know to make my presentation a little bit shorter because Steve's going to add in cool points like that. So, and he talked about some of their previous lives, and many of us may know that have been around for a few years. Some of the older names like Extant and PPI, some of the guys that worked on those big projects way back in the day actually came on board with us many moons ago. And like Steve said, those guys have all worked together for quite some time. And we definitely have the best team in the business. And it shows going, from Slash amplifiers all the way up to VXI and everything in between. They all have something cool to add to the experience and to that listening experience. So let's get started on just some of the key technologies that make JL Audio amplifier so special. We're going to start off with R.I.P.S, or Regulated Intelligent Power Supply. This can be found on the Slash and HD amplifiers, and it is an extremely important technology because it really sets them apart from other amplifiers. Most amplifiers available have an unregulated power supply, which means the output will fluctuate depending on the voltage of the amplifier seeing from the car's electrical system. For instance, if your car's electrical system's putting out 14.4 and you're getting great power into your amplifier, then you're going to get a great output from the amplifier, say maybe 100 watts, for instance. Now, if the now, but that's what I measure with my meter all the time.
I hope you get my point. 14 volts in a car is very hard to maintain.
It is. Now, if the car's voltage sags a little bit to like 12.6, you're no longer going to get that same 100 watts out of the amplifier. And that's the point with the regulated power, or with an unregulated power supply. The output voltage fluctuates with the input voltage. Now with R.I.P.S, the power supply actually adjusts its operation to maintain the amplifier's rated power output and low distortion operation over a wide range of the vehicle's voltage. So if your voltage is fluctuating from 11 volts to 14.5 volts, we will continue to maintain that low rate of, or that low distortion, and also that same output of the amplifier itself. And like we said, it really contrasts with unregulated power supplies. When that voltage rail sags in proportion to the voltage supply coming in, it can actually result, like we said, in power loss, but also can start resulting in some distortion happening with the amplifiers too. So by maintaining that across the board, we're able to really maintain our low distortion and the output voltage on there.
So basically what happens is if you want to maintain the full amount of power, if you know what Ohm's law is and all that stuff, and you don't have to, but I'll let you know that voltage and current are going to determine power in watts. So if you have a fixed amount of power in watts that you're looking for and your voltage drops, you'll need more current, and that our regulated amplifiers will draw more current to maintain that full power. In an unregulated amplifier, if the voltage was to drop, the power output also drops. So the demand on current is significantly less, but your peak power capability, your ultimate power capability will sag with it. And that could lead to the distortion that Kevin's describing, that change in power delivery. So in some of our highest level amplifiers, like Kevin has on the screen there, the /V3 and the HD products, these are some of our best performing products because they maintain consistent power delivery regardless of the supply voltage. So as a user, you don't have to think about what's going on with it. Hook it up, make sure everything's good, and you've got great performance all the time. And that, of course, comes at the cost. There's some complexity on the circuit boards that has to be accounted for, and obviously there's additional parts. So some of these products tend to be on the higher end of our spectrum, but the performance is absolutely there to back it up.
Yeah, like he said, it's not cheap to do this, and there's actually multiple rails in there that will automatically switch depending on what the amplifier is being presented with too. So there's a little bit of complexity that happens with that internally to maintain that output, not only with input voltage, but also with the impedance that's being seen on the amplifier itself too. So no matter what, if you're between 2 or 1.5 ohm and 4 ohm, or 12.8 volts or 13.8 volts, you're going to get the same 750 watts out of an HD 751. So it's very, very nice. And it's also going to keep that same lower rate of distortion across the board too. It just results in better fidelity and better stability across the board. You think about it, even low dips on the input side of things can cause a little bit of that rail sag and distortion. And what I mean by, small dips or short dips is, think about this. Your subwoofer plays a really, really low note. Even if you have a great charging system, it's still going to sag a little bit because the current draw is becoming more greater. So you're going to have a little bit of sag with that with your unregulated power supplies, where this is just going to maintain that 750 watts across the board with your HD 751.
Before you move on, let me just jump on that. You had mentioned about the impedance range, the 1.5 to 4 ohms per channel thing. So this often causes some confusion. A normal amplifier, let's just say not one of these amplifiers, there's often different specifications in terms of power delivery. You'll see typically a higher number at 2 ohms than you would at 4 ohms. So let's use an example of a 100 watt per channel at 2 ohms amplifier. But if you use it at 4 ohms, it's only 50 watts per channel. So why would you ever use it at 4 ohms? You never would. You'd say, well, I want to use it at 2 ohms all the time. But sometimes the application doesn't allow for that, as is the case with door speakers. So typical door speakers is going to be a 4 ohm speaker. So if your amplifier is rated for 2 ohms, well, you're going to get less power. So a lot of people think that some amplifiers double their output power, when in actuality they don't. They've been rated to deliver that power at a very specific impedance. With R.I.P.S, the regulated intelligent power supply, the I is referencing this part. It knows that the impedance of the speaker could vary, right? In this case, it could be a 2 ohm speaker, 4 ohm speaker, whatever the case may be. And it's automatically going to adjust to make sure that every speaker that you connect to it, anywhere from 1.5 to 4 ohms, is going to maintain the full power capability of that amplifier. You don't lose anything. So just pick the speakers you want to use, hook it up to an electrical system that you already have, and you're going to get full power from one of these amplifiers. That's kind of why we like them. And again, there's some trade-offs in this. It's more complex and things of that nature, so you have to consider all of that. But ultimately, for the fidelity and the ease of system setup, all day long, give me an HD, give me a R.I.P.S amplifier any day. I really, really enjoy it because I don't have to think. I just hook it up and it works.
I'll channel Rob's inner sales guy here and say the nice thing about these amplifiers is you can go through multiple subwoofers and change your system around, and you'll still be able to maintain that same output voltage. Whether you're going from a single sub to a dual voice coil sub to multiple subs, you can wire them up some sort of way to be in the range of that, 1.5 to 4 ohm impedance to be able to get your output out of your amplifier. So they're very, very flexible that way. Did I do that sales pitch justice, Rob?
In all seriousness, though, I do love that aspect, because often, especially when we're, a newcomer to car audio, if you're tight on your budget, sometimes, you don't do a full-blown system at once. You build it in stages. So maybe you buy an HD amp and a subwoofer you can afford, and when your wallet allows it, you add a second sub or you upgrade to a different sub. And this R.I.P.S technology really adds flexibility, so you're not having to replace the amp every time you upgrade. You can just add what speakers or subwoofers are needed to the mix. So I think that's a really cool feature.
Absolutely. So let's get into single cycle control. So single cycle control is exactly that. By tracking the audio signal and comparing it to every single cycle of the pulse width modulated waveform, and then we're able to make corrections to that waveform or to that switching if needed. And we actually read over 400,000 times per second. Let me say that again, 400,000 times per second. So it's pretty quick. And keeping the switching synchronized by making real-time corrections to any varying deviations of the component timing in the amplifier. And it's really a unique approach to controlling a full-range Class D amplifier. By tracking that audio signal and comparing it to the waveform, and then by correcting each and every cycle, we're able to keep the switching synchronized and make those corrections real time and really give you a better sonic performance out of the amplifier. The technology also results in outstanding efficiency, which is really, really good. With actually 60% less current draw than a typical Class AB car amplifier of equal power output, depending on which one you're looking at there. And this tremendous efficiency advantage also leads to less generated heat. And we all know that heat is very difficult to deal with. So that allows us to really scale down the chassis size to about a quarter of the size of what the similarly powered Class AB amplifier would be. So if we take that, we have a lot less heat. We're able to scale down the size because we don't need as much heat sink. We're a lot more efficient, and the entire amplifier is in sync with one another. So it's really working seamlessly, better clarity, and also a lot more efficient. And why, again, there may be less expensive ways to make full range switching amplifier better. No other Class D control system works faster or more accurately than the single cycle control.
It's a really cool technology that we brought out on those HDs. And by the way, every one of those circuit boards you put in this slideshow is awesome. I just love the look at all of it. But single cycle control, like Kevin said, it's just a really great way of having a very efficient and very great sounding amplifier. And again, like you mentioned, there's other easier ways of doing things that doesn't result in quite the same level of performance or efficiency advantages. So HD is a pretty special product for us for all those reasons.
And moving on to RealSync. RealSync is actually found on HD and also the Slash amplifiers. And it is dealing with the heat sink on it. Most car audio amplifiers rely on a big lump of metal to do a good job of storing heat, but not such a great job of getting rid of it. With RealSync equipped amplifiers, the output devices are all lined up on the inside of the amplifier attached to that cast alloy heatsink with the vertically orientated fins. This design is far more effective than just taking a large piece of metal and mounting those output devices on there. So it's a lot more efficient. And utilizing the physics of convection and radiation to more effectively exchange heat with the surrounding air. And we actually designed these heat sinks and refined them through extensive finite element analysis. And it really helps resulting in the amplifiers keeping their cool under the most demanding conditions. You think about it, if you just take a large piece of metal, your surface area is going to be a quarter or a tenth of what it would be by having those fins machined into there, going vertically on there. And then those output devices, as you can see in here, right underneath a JL Audio HD plate there, you can see them mounted right behind that and soldered onto the board. So that way they dissipate that heat right into that cast alloy heatsink directly.
The other thing I really like about the way that the sinks are designed is they're tapered, so they're not just squared off. They actually have an angle or a radius to them. So if you mounted this amplifier, let's just say you had it with all the connections going straight down, the airflow can go actually underneath the fins as well as across the back and then between each one of them. Or if you mounted it flat, you still have lots of surface area with the ability of convection taking place where the heat can come off of the heat sinks. With an HD amplifier, there's really only two circumstances that you probably wouldn't want to do. One would be to have it so where the wires are coming out the one side or the other side. Those are the two situations that wouldn't be perfectly ideal because you have heat sinks on either side of the amplifier. On the older Slash amplifiers, all the connections, all the heat sinking was done on the back. So the only way, the fins would be up like this or flat on the ground. The only bad way that way would be with the fins pointing down because then the heat is rising up into the amplifier itself. But with the HD, we split it off to either side, and almost any application you're likely to do, the airflow around those heat sinks is going to be ideal for you. It's pretty cool technology.
It is pretty cool. And when you think about this, when Slash came out, a lot of amplifiers back then were using big, heavy, large, chunky type of heat sinks, or they were using some sort of cooling fan in them back in the day too. So, and those cooling fans would be noisy if you were in like a pickup truck and it was under your seat or anything like that. When the fan would kick on, we'd be able to hear that. So it was a great technology and has done very, very well for us over the years by keeping these amplifiers nice and cool.
It's interesting you brought up the older designs, actually, because I've often felt that necessity is the mother of invention, right? The older designs, the physical size of the amplifier was so darn big that a big slab of metal was fine because you had so much metal that the heat could be dissipated out without really any issue. But as you start shrinking it down and you have a limited amount of contact area, you have to come up with more refined ways of getting rid of that heat. And the RealSync thing that they did with the Slash amplifier has carried on, and it's become even more important as we've gotten into even more compact form factors with even more power. So power has gone way up. Size has gone way down. That necessitates the need for better cooling environments. So the engineers hit it with technology, and we came up with the RealSync technology.
I think it's important to remember, what Kevin said was, one of the key things with the outputs being mounted to this, when I hear people say like, oh, there's something wrong with the amp, it's super hot when you touch it. That's a good thing. That means it's pulling the heat from the board. We want that. It's doing what it's supposed to be doing. It's helping cool down the internals to keep it running and putting that heat somewhere else. So if you feel your amp super hot, don't freak out. That's typically by design to help make sure the inside, which really matters, is what's operating under a proper temperature.
Hot is okay. Too hot is not okay. And we have technologies to manage too hot as well. But, Rob, it's an excellent point. Older style amplifiers that we usually cover with a whole bunch of fins, when you put your hand on those fins, you only made contact at very small points. So your hand didn't pick up on how hot that amp actually was. So with some of the newer designs where you have nice, flat, smooth surfaces like on an HD, when you put your hand on there, your entire hand is making contact with a pretty warm surface. So we say that it feels like it's hotter than it should be. Compared to what? You never had access to that before. And again, that's all part of the smaller form factor and where the heat is and how to control it, and all of that.
And I know Steve gave a great example of why those rounded off fins are nice, but I can also neither confirm nor deny that I am old enough to remember installing amplifiers that had sharper fins on them. It would come across with some scratches on them. So that's my personal opinion with liking those rounded edges on there too.
Sidetrack you, but if you want a reminder of those, we have a couple of power supplies at the main headquarters that still have that style. Oh my God. You will definitely cut yourself.
So let's get into NexD and NexD2 amplifier technology. Our NexD switching technology stems from our Class D expertise, and it really delivers outstanding fidelity and efficiency. Again, you'll see these two things being our main lead-in for most all of these technologies. And it really helps leading to compact amplifiers that deliver high power at an exceptional value. So we've taken that simple approach of that fixed pulse width modulation and enhanced it with a very high switching frequency. It's actually 240 kilohertz, which is about 4 times higher than most other Class D subwoofer amplifiers. And this pushes the amplifier's bandwidth to at least 500 hertz with really minimal distortion and great efficiency, all while keeping the typical bulky circuitry more compact. Now, the full range amplifiers switch at well over 400 kilohertz, and monitoring the input signal and instantaneous power supply voltage to help cancel out any distortion due to that power supply voltage fluctuation from the car. So by monitoring the input and the power supply voltage we're seeing there, we're able to cancel out any of that distortion coming in from the rail sagging from that voltage input there. Now, NexD.
Actually, sorry, Kevin, just wanted to kind of give a little bit of history on Class D in general. Class D amplifiers are not as new as some people might have thought. They've been around for a really, really long time. And the D does not stand for digital, okay? It's just the next letter that they had for amplifier designs. And some of the earliest attempts at Class D for audio application, they did try to make them full range. But because it's a switching amplifier, the switching frequency was not high enough to prevent it from causing issues with the higher end of the audio spectrum. So your high frequency drivers will extend up to 15 or 20,000 hertz. The switching frequencies were only slightly faster than that, so that there could be some noise that would show up at the high end of your audio spectrum. So the first pass of successful Class D amplifiers were really focused on subwoofer applications, way away from the switching frequency. The level of detail and fidelity of the higher frequencies, who cares? It's playing a subwoofer all day long, no problem. And the huge advantage was efficiency. The switching amplifiers had a tendency to be much, much smaller because of their higher efficiency and less heat generation. So the heat sinking could get smaller. But then what if we want to play a full range signal? Well, that's where it gets tricky because you have to have a switching frequency that's really, really high and some filtering and other things like that to make sure that the performance is going to be there. But a lot of the workarounds would affect the fidelity of the amplifier or the efficiency of the amplifier. So things like NexD switching technology is a derivative of some of the earlier attempts that JL Audio and other companies had with Class D. So this is more of an evolutionary design of Class D. And one of the big advantages is because of the way things are laid out now, we can use smaller devices. They're more efficient, they're physically smaller, and things get more compact. So when we started using NexD, one of the things that most people noticed was the amplifier still sounded great, but they got about 25% smaller for the same amount of power, but they still sounded the way we wanted. That's why we really like the NexD technology. And it really did great things for us and for our customers because they got better performance in a smaller package, and it wasn't hideously expensive either. So really very cool technology. And the NexD2, I think you're going to talk about that a little bit more, Ken, right? So NexD2 kind of takes that to the next level, hence the 2. So I'll let you talk though. Sorry, Kev.
Yeah, I mean, you think about it, when XD came out, the size and power outputs of them, really there wasn't much out there that could even come close to those amplifiers. Now, Steve kind of hinted on NexD2, and this is NexD, the second version of NexD, not NexD also. And the new switching technology is an evolution of NexD. It's not just the same product put into a different chassis. It is a complete evolution of that NexD Class D technology with significant improvements in fidelity and efficiency, and even radiated noise performance, which is a big thing for our partners overseas and stuff like that, right? So NexD2 actually employs a new generation of power supply and output devices, which are incredibly compact and surface mountable. These direct FET devices feature the latest MOSFET silicon technology. The smaller package reduces the parasitic capacitance and inductance. And really what that means is it improves your current carrying capability and efficiency. They are encased in a metal enclosure to optimize that heat dissipation also, and that metal enclosure also helps minimize that radiated noise too. In addition to the new silicon NexD2 benefits from advancements in the area of the circuit board layout, we have a real minimum loop area design, and the approach places the capacitors closely coupled to each output section, and the amplifier circuits have been engineered to really minimize the length of the ground return paths also. This approach really reduces the interaction between the audio channels to improve separation and reduce distortion and, again, the radiated noise. In the multi-channel multi-channel VXI and MVI amplifiers, we've also leveraged the power of the onboard DSP to synchronize all of the channels via the DSP's master clock. Kind of similarly to the single cycle control, but in a little bit more advanced application there. And this eliminates undesirable interactions between the channels that can be caused by variations in switching frequencies and that on-off relationship when we are switching those devices.
Let me unpack that, Kevin. That was a whole bunch of stuff here to share with everyone. I'm going to try to maybe pull back and kind of speak in Steve terms, which are more basic. So NexD did a lot of great things with making all the componentry smaller and lots of real great benefits in the high frequency switching and all that other stuff that we just talked about. NexD2 continues all of that and extends it even further. So we still have that same general idea, hence the same common part of it in the NexD. But the D2 part of it is we've also taken advantages of some other things. Not only have the parts gotten even better and even smaller, that's part of it, but because these are being used in our DSP-based amplifiers as a chip in there, it's already being used for other purposes, and we can also use the DSP to help control what's known as the master clock. And since a Class D amplifier is a switching amplifier, that means at some points it's going to be switching on while some things are switching off, and then other things are switching off while other things are switching on. And the master clock is kind of like the conductor that says, okay, you switch off, now you switch on, and everything's got to be in concert with each other to make sure everything works well. If they're on at the same time or off at the same time, obviously that's not good, and it can show up as inefficiencies, and the heat can go up or the sound can get not so good. So technical term, not so good. What the DSP can do is, because we're not dealing with what would be normally set up with analog circuitry, like your typical caps, coils, resistors, that kind of thing, but it's a DSP, it stays in the digital domain. A 0 is a 0, a 1 is a 1. There is no gray area, so the on and off control is very, very carefully controlled, and your efficiency gets even better and your fidelity gets even better. That's huge. Additionally, because all these parts are now smaller, we've done a lot of work on the circuit board, and that's what that minimum loop design thing is all about. They've looked at how the circuit board can be laid out. In the past, we had to modify the board layout to make room for physically large parts and putting them where they needed to be because of their size, as opposed to where they should be based on their performance. So we could put capacitance closer to the areas that need it. We could put inductors closer to the area that we need that. All these different parts can be put where they belong, and we could minimize the ground path so we can control noise a lot better. So that's a lot of what Kevin just unpacked, and that's really coming from this NexD2 technology that allows us to do all of these things together in one chassis. And this does represent some of the highest level in terms of our overall integration of Class D into our full range and our base amplifiers. And you'll see that as Kevin has on the board here on our top level DSP-based amplifiers.
So before we move to advanced rollback, one thing Kevin brought up, and it also came up in the WebEx chat, Class D amplifiers can potentially have some interference with AM/FM reception. And Neil was asking some of the issues with that and what we've done, especially with the benefits of the NexD2 to help resolve some of that.
Is that for Kevin or for me?
Either one.
So when we first came out with Class D amplifiers a long time ago, the slash amplifiers were the original ones. The first thing we noticed that some people were complaining about AM reception not being as good as it was without that amplifier. And I forget exactly how the
DAB
joke
too,
went.
right?
Was that?
DAB gets interfered with that too, right?
This is so long ago that DAB really wasn't a thing yet. So I remember one of our engineers made a joke. It's like, that's why we invented FM. But the problem is FM is also something that can be affected if things start getting into that range of things. I'm going to be very vague with some of the technical terms just to give you the idea. So yeah, there is a potential that AM will be affected by some switching amplifiers and also now FM. And then you bring on DAB. Well, DAB, again, because there's a lot of switching going on, digital stuff is switching as well. So there's a potential for some noise interference. Now, the truth is, it's not a JL audio problem. It's not even a problem per se until you start working with technologies together. So this is not something specific for JL audio. It's something that all manufacturers will experience to some degree or another. And as time has gone on and we've seen more and more of these issues show up, we've changed the way we've done board layout, something that we just mentioned, the minimal loop technology that we do. We're also improving the chassis. So a cast chassis is going to do better than an extruded chassis because there's more leak points in an extruded chassis. So as we've gotten better over time, we've seen less and less interference with these other technologies and things are getting better. And there's filtering that you could do that can either limit the performance of the amplifier or change some other factors that are equally as not good as an interfered with signal. So I don't have an easy answer to say that we're going to get rid of it forever, because I don't know that we are going to get rid of it forever, but we've been able to minimize it to the point where it's below a threshold that people are really complaining anymore. Although it does happen on occasion, we've seen fewer and fewer complaints over the past couple of years as we've gotten better with our technologies. Rob, did that answer it effectively? I hope.
Yeah, I think so. I mean, I know, especially with the DAB, as we've come out with the XD and the RD and the VXI for our international partners, the complaints have really fallen off sharply about reception issues compared to what they were, 3-4 years ago. So.
Yeah, I have a few guys that have commented on replacing older amplifiers with VXI and have noticed a significant reduction in the DAB interference from overseas. So it definitely not only going to that different NexD2 components, but also, like Steve said, that chassis just having less leak points on it helps out quite a bit too than what an extruded chassis would have.
Chassis, it's more than just a pretty face.
Right.
I think I caught a funny joke in the Facebook comments. I didn't know about AM and FM. Oh, no, didn't know about the AM FM issue. But my point was that a lot of people don't listen to AM or FM. So maybe that's why the complaints are going down.
Right. Streaming music has replaced AM FM, right?
I think so. But obviously it is still something we know about and continue to make strides to improve.
Alrighty, so let's get into the advanced rollback protection. This circuit actually monitors the amplifier's thermal condition and adjusts the amplifier's operation to eliminate any type of amplifier shutdown events. And we'll kind of break that down and simplify it here in a second. Should the amplifier reach an unsafe operating temperature, the special circuit rolls back only the peak power output without changing the gain, and that's extremely important. And it will do this until the amplifier cools down to a safe operating temperature, then we'll go back to normal operation. And this condition is usually generated by a red or a thermal LED. Like on the VXI amplifiers, the ring will flash red. And like we said, once the amplifier cools down, the circuit restores full peak power output and the indicators revert back to their normal state. Since the advanced rollback circuit doesn't change the gain, it is actually inaudible in most cases there. But it ensures that your music is going to keep on playing even under the most demanding conditions. So like we said, the nice thing about it is it's not changing the gain of the amplifier. It's just rolling back those peaks. And that little bit of rollback will actually be inaudible, but help the amplifier recoup, cool down, down and then come back onto as full power permits.
To repeat my earlier joke, this is a really cool idea. So the standard way that an amplifier will protect itself when it gets too hot, as Rob mentioned earlier, they're all going to get hot if they're working, right? It's a matter of getting too hot. The normal thing is if the amplifier detects a temperature that it has been programmed to say is too hot, it'll shut off. It produces no more heat, and it'll wait until the temperature comes down to a point, and it'll re-engage the circuit and start playing again. And that makes a lot of sense from a reliability point of view. If things get too hot, something could break, and we don't want the amplifier to break. So to keep our customers happy, we would make sure that the amplifier doesn't break. That sounds very logical until the customer says, but I can't hear my music. So when you have something like advanced thermal protection, where it rolls things back, instead of shutting off, it'll simply scale things back. And like Kevin said, it pulls down the peaks. And at the level that you're playing it, those peaks aren't very high anymore compared to the average. And the average gain, the average sound that you're actually picking up on isn't really changing at all. So you're not going to notice any of this. It happens in the background. And typically the only indication that anything has changed is the fact that there's a light on the amplifier, if you happen to even see it. But this is fantastic from a customer's point of view and from a listener's point of view. We just listen to music until we don't want to listen to it anymore. We control when it goes off. The amplifier is going to stay on and stay reliable without any issues. I really enjoy the fact that the advanced rollback protection exists on just about every amplifier that we have. It's an awesome technology, and you'd have to see the light come on to know when it's working until you realize that a normal amp would have been off.
I agree.
Time for a quick little story on this?
Yeah.
A quick one. I know, I see the time. When we first developed the Slash amplifiers, the advanced rollback protection was part of that as well, and it's gotten better over the years. But I remember we were doing a demo on the floor of a trade show, and a coworker of mine was doing a demonstration for some customers, and I was standing at the back kind of talking about the installation we did. And I was saying, all these new amplifiers, they have this, that, the other, or whatever we were talking about. The guy I was talking to says, what's that light on the amplifier mean? And I look over, I'm like, oh, wow, that's cool. That's the thermal protection light. He said, but the system's still on. I said, that's the point. The only way you know, because the guys listening to it, they didn't turn around to see what was wrong. They just kept listening. They had no idea it was in thermal. Only someone that saw the light happened to know. And to me, that was magical, because that's exactly the point. The system keeps on playing, stays reliable, and no one knows unless you see a light. Brief story, I'm done.
And that's just a real good point. Is it's not it's not toning the entire amplifier back like some protection circuits, and it's not shutting the amplifier off completely. Like we said, it's just rolling back those peaks and keeping your gain completely steady. So it is pretty much inaudible in most cases, and sometime I'll learn to say that word properly.
Audible aspect's big. I remember having a system back in the day where if I would drive more than an hour and a half, my subwoofers would go, the amps were baking because they weren't well ventilated, and my subs would drop 6-8 dB. They were there, but there was almost no bass, and it was so annoying. Every time I had to drive long distances, I would lose my bass. So the inaudible app, the fact that it reverts back to full power, that's awesome.
Right. Yeah, it doesn't require a turn off and turn back on to revert back. Good point, Rob. So let's get into the JL Audio's differential balanced inputs. These are really engineered to combat induced cable noise, which is a common problem in car and marine audio installation. This technology allows for the use of conventional RCA cables while delivering many of the benefits of a true balanced connection and accepting a wide range of input signal levels also. They're engineered, like we said, to combat noise. If you guys have been around and have installed quite a bit or have had many systems in your car, I'm sure at some point in time you've had noise induced from an RCA. I know way back in the day it was really bad, and that's kind of where the roles of separating power wires and doing all of that stuff came along. And this really helps reduce that induced noise from your RCA cables. Another cool benefit of the differential balanced input design is it easily accepts low-level and high-level signals from a variety of factory receivers. and outputs and amplifiers, including single-ended ground reference sources, as well as balanced or unbalanced sources too. And this really helps eliminate the need for line output converters in many installation scenarios. They'll actually, most of the amplifiers will go from 200 millivolts to 2 volts RMS, and then you can switch them to high to go all the way up to 8 volts RMS on the inputs. And when you get into VXI and MVI amplifiers, you can actually go all the way up to 16 volts RMS on those inputs without having the need for a line output converter. So it's a nice technology, helps reduce noise, and also helps reduce the needs for those line output converters to scale down the input going into the amplifier also. So moving on to JLID. The JLID is a protocol for digital controllers and for communication settings between devices. It is not used for audio signals. It is strictly for the communication of the network or of the devices that are connected to it. This is found on both MVI and VXI amplifiers. And it really offers powerful networking capabilities to deliver a single point control for multiple amplifiers in a system. So if you're doing a large vessel with a lot of MVI, you'll have one point of control that you would be able to control all of the different amplifiers in the system that you are building. And the same with a car with a VXI amplifier. So you'd have one DRC that would allow you to adjust your levels like volume, fader, balance, zone levels, and to be able to select multiple DSP presets across that entire network. So if you have multiple full range amplifiers and you want to be able to go through and select your presets, you don't have to have multiple DRCs. This creates a single point for one DRC to be able to go through and select those presets and to select all of your different level adjustments on there too. The VXI amplifiers each feature a separate control and a COM port. So for networking and your wired controller. While the MVI only has one, so when you are networking MVI, the DRC will actually connect to the MVI hub instead of like VXI would connect to your master amplifier. So a little bit of